You know, in the wild, high-stakes world of AI, there's this one question that just keeps popping up. It sounds super simple, right? But as we're about to find out, the answer is, well, it's a whole lot messier than you'd think.
Yeah, which AI model is actually the best? I mean, this is the question businesses are asking themselves when they need to crunch sales reports. It's what developers are wrestling with for their new apps. Heck, it's what you might be thinking when you just want a good answer to a question. And with new models dropping like every week, how in the world do you pick a winner?
And the sheer number of options it's just mind-boggling. We're not talking about a handful of choices here. We're talking hundreds of unique large language models, LLMs. And each one has its own variations. It's that classic paradox of choice. You have so many options that picking one feels completely impossible.
So to try and make sense of all this chaos, we've come to rely on these LLM ranking platforms. Just think of them as leaderboards, but for AI. The concept is pretty straightforward, right? You give a prompt to two different models, you pick the response you like better, and the platform takes thousands and thousands of these votes to build a ranking. It seems like a great system, a really democratic way to find the best, doesn't it?
Well, hold on a second. A brand new study from some researchers at MIT is kind of throwing a wrench in the works. It turns out that these leaderboards, the very things we're all using to get some clarity, might be built on, well, let's just say some surprisingly shaky ground. They found a hidden weakness, a real fragility in the whole system.
Okay, so what they did was they zeroed in on one of these really popular crowdsourced ranking platforms. And just to give you a sense of the scale we're talking about, its ranking was built on over 57,000 user votes. That is a ton of data. You'd think with that many votes, the final ranking would have to be rock solid, wouldn't you?
So this is where it gets interesting. The researchers asked a killer question. Out of that massive pool of 57,000 plus votes, how many would you have to take away to flip the leaderboard, to change which model was number one? Seriously, take a guess. A couple hundred? Maybe 1,000?
The answer? 2. No, seriously, just 2. Let that sink in for a minute. Out of more than 57,000 votes, it only took 2 of them to completely change who was on top.
And to put that into perspective, that is just 0.0035% of all the data. I mean, that's practically nothing. A tiny, tiny fraction had the power to change the entire result. So yeah, that ranking, it wasn't anywhere near as stable as everyone thought.
Okay, so your next question is probably the same as mine. How on earth did they find those 2 specific votes? It's like finding a needle in a haystack, right? I mean, checking every possible pair of votes out of 57,000, that would be computationally impossible. You just can't do it.
This is the clever part. They came up with this really smart and super efficient method. Instead of just trying every combination, which would take forever, they built a kind of approximation tool. It looks at the existing ranking and figures out which votes are probably the most influential. The ones that are basically acting as tiebreakers between 2 really close models. Then they just pull out that tiny handful of votes and recalculate. It's a really elegant way to see just how stable the system is, to basically stress test it.
So, you might be thinking, was this some kind of coordinated attack to manipulate the rankings? Well, probably not. The researchers think the real culprit is something much more boring, actually. Simple human error. Someone accidentally misclicked, or maybe they were distracted, or maybe they just genuinely couldn't tell which answer was better. But here's the kicker. At the end of the day, you really don't want that kind of random noise deciding which multi-billion-dollar AI gets to be crowned number 1.
Okay, so is this just a problem with these big crowdsourced platforms? To find out, the team also looked at a different kind of leaderboard, one that was put together by experts, people who are paid to give high-quality feedback. And yeah, it was definitely more robust. But it was still surprisingly fragile. For that one, it took removing 83 votes. That's about 3.2% of the data, to change the top spot. Now that's way better than just 2 votes for sure, but it still shows that even the expert systems can be swayed by a pretty small group of votes.
So, what does all this mean for you? Well, the big takeaway is that these leaderboards are useful, for sure, but they are not the be-all and end-all. That number 1 ranking doesn't automatically mean a model is going to be the best for your specific needs. You can't just blindly trust that number 1 spot. It really highlights that the race to the top might just encourage companies to gain the system instead of focusing on building genuinely better AI.
Now, the good news is, it's not all doom and gloom. The study actually points to some real solutions. The platforms can get better.
For example, instead of just a simple A is better than B vote, what if they asked for more detail, like how confident are you in your choice? Or they could even have human experts come in and review some of the crowdsourced votes to weed out the errors. There are ways to make this whole thing more robust. And Tamara Broderick, the lead researcher on this at MIT, she really summed it up perfectly. She said, and this is a great quote, "One can't assume the top-ranked LLM is going to be consistently outperforming all the other LLMs when it is deployed. In other words, winning the top spot on the leaderboard is just a snapshot in time. It's not a promise that it's always going to be the best for you."
And all of this leaves us with a much, much bigger question, doesn't it? This research really peels back the curtain and shows just how fragile our current ranking systems are. And it makes you wonder, if these leaderboards, which are driving huge investments and decisions, are this easy to flip, then how are we really supposed to measure AI intelligence? What's his best even mean anymore? That, I think, is a question we're all going to be wrestling with for a long time to come.